So far, you've been looking at forces on free objects. So for example, you've looked at the inclined plane, where if I have an object on this plane, it's being acted by gravity or some sort of other force, and it's free to move up and down that plane. What we want to now consider is what happens to our object if we were to instead fix it at some sort of pivot point. So suppose we have a wrench here that's connected to some sort of nut or some sort of bolt. Okay, we're now applying a force to this wrench in some direction, and we want to figure out the action of that force all the way over here onto this bolt. The way we do this is via torque. So torque is denoted by tau and is equal to the cross product of r and f, where r is our length vector from the point of application of our force to the pivot point. So that's this vector all the way from here to here. And f is our force vector. So that's a force that we're applying here. And you can realize that now the units of torque are going to be in Newton meters. It's because the units of force are in newtons and the units of this length vector are in meters. Because of this formula as well, because it's a cross product, what we know is that the magnitude of our torque is equal to the magnitude of this length vector times the magnitude of our force times the sine of the angle between them. Okay. What this means is that to increase our torque, or otherwise the action of rotation on our pivot point, we can do three things. We can either increase the length of our wrench. You can imagine that a longer wrench, when you apply a force to it, is a little bit easier to rotate something by. Secondly, you could increase your force, so apply a larger force to some point on the wrench. And then thirdly, to maximize the perpendicularity of this length vector, as well as your force vector. That's coming from the sine of theta term here. You can imagine that if I were to apply my force at a weird angle, that's not perpendicular, I'm getting less of an action all the way over here on this bolt. Okay, let's do a quick example. Suppose that this wrench was 10 centimeters long. Suppose we're applying now a perpendicular force to the end of this wrench, that's 10 newtons. Our torque, or the magnitude of our torque, is hence going to be 10 times 0.1, or 1 Newton meters. Okay, and it's going to be a vector that's perpendicular to this point here.